Alright, so in this problem, I have x to the power of 6 is equal to x minus 1 to the power of 6. So I'm going to first start by subtracting x minus 1 to the power of 6 on both sides. So then these two cancel out, and now I have x to the power of 6 minus x minus 1 to the power of 6 is equal to 0. Now x to the power of 6 is the same thing as x to the power of 3 to the power of 2, and x minus 1 to the power of 6 is the same thing as x minus 1 to the power of 3 to the power of 2. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So this is going to equal x to the power of 3 plus x minus 1 to the power of 3 times x to the power of 3 minus x minus 1 to the power of 3, which is equal to 0. Now, if I have something in the form a to the power of 3 minus b to the power of 3, this is equal to a minus b times a squared plus ab plus b squared. So this is going to equal k plus k minus 1 times k squared minus k times k minus 1 plus k minus 1 squared. Sorry, this is actually supposed to be x, but yeah. So this simplifies to 2x minus 1 times x squared minus x plus 1 times 3x squared minus 3x plus 1 is equal to 0. Because we also added in, remember, we also have x to the power of 3 plus x minus 1 to the power of 3. So now this gives me three different equations. I have 2x minus 1 is equal to 0, meaning x is equal to 1/2. I have x squared minus x plus 1 is equal to 0. And I have 3x squared minus 3x plus 1 is equal to 0. So for x squared minus x plus 1 equals 0, we have x is equal to 1 plus or minus the square root of 3i over 2. And finally, for this, we have 3 plus or minus the square root of 3i over 6. Alright, so in this problem, I have 11 to the power of 9x plus 11 is equal to 9 to the power of 11. So to solve this problem, I'm going to first start by taking the log on both sides. So I have log 11 to the power of 9x plus 11 is equal to log 9 to the power of 11. Now if I have something in the form log a to the power of b, I can move b to the front. So this is the same thing as b times log a. So log 11 to the power of 9x plus 11, I can move 9x plus 11 to the front. And log 9 to the power of 11, I can move 11 to the front. So now I have 9x plus 11 times log 11 is equal to 11 times log 9. Now I'm going to divide both sides by log 11. So then these two cancel out, and now I have 9x plus 11 is equal to 11 times log 9 over log 11. Now, log 9 is equal to 0.9542, and log 11 is equal to 1.044. Sorry, 414. So now I have 9x plus 11 is equal to 11 times 0.94542 over 1.0414. And this is the same thing as 11 times 0.9163, which is equal to 10.0789. So now I'm going to subtract 11 on both sides. So I get 9x is equal to negative 0.9211. Now if I divide both sides by 9, I get x is equal to negative 0.1023. So this is my answer to this problem. Alright, so in this problem I have 9 to the power of x plus 12 to the power of x is equal to 16 to the power of x. So I'm going to first start by dividing every term by 9 to the power of x. So 9 to the power of 9 to the power of x, those two cancel out. So I have 1 plus 12 over 9 to the power of x, which simplifies to 4 over 3 to the power of x. And 16 over 9, which simplifies to 4 squared over 3 squared to the power of x. Now, this is the same thing as 1 plus 4 over 3 to the power of x is equal to 4 over 3 squared to the power of x. And if I let 4 over 3 to the power of x equal to the variable y, I get 1 plus y is equal to y squared. This is the same thing as y squared minus y minus 1 is equal to 0. Now by using the quadratic formula, if you use it, I'm not going to do it now, but you should get that y is equal to 1 plus or minus the square root of 5 over 2. Now remember how we let y equal 4 over 3 to the power of x. So we have 4 over 3 to the power of x is equal to 1 plus the square root of 5, 1 minus the square root of 5 over 2. And 1 minus the square root of 5, that's going to be a negative number, and you can't take the power of a positive number and make it negative, meaning the only solution for y that works is 1 plus the square root of 5 over 2. So now to solve this, I'm going to take the log on both sides. So I have log 4 over 3 to the power of x is equal to log 1 plus square root of 5 over 2. And now I can actually move this x to the front. So now I have x times log 4 over 3 is equal to log 1 plus the square root of 5 over 2. Now if I divide both sides by log 4 over 3, these two cancel out, so I'm left with x is equal to log of 1 plus the square root of 5 over 2 over log 4 over 3.